So, guess we might as well get started. Was there anything you wanted to go over or cover today, Yuri?
No, not let me think about it. Actually, you want to go ahead? I'm actually like still like trying to finish lunch. So,
okay.
Yeah, sorry.
All right. Well, I mean, I was wondering if you had any experience. Have you ever done calibration on a model? I know I'm asking you a question, but
I've heard the word, but I don't know what it means compared to.
yeah, me too, as of yesterday. So, okay. Yeah, so somehow what I understand, I just started researching it. What I understand about calibration is you take your model, I'm not sure when or what kind of task you use it for, but you take your model. Actually, I saw calibration for classification. So, but you take your model after it's been trained and you use the test set or validation set. And it looks at the it like does it looks at the it bins the probability scores, like 0 to 0.1, 0.1 to 0.2, and then within that it comes up with a calculation of which are how many are right and how many are wrong within that bin, and it turns that into a ratio. So you get a ratio of correct and incorrect within each bin, and then from that it's able to tell where your model is more certain and less certain, right, with its probability, right? And so and then so this
why do you want to do binning for that? So you can like say you can like collect like group results together, like collect statistics.
Yeah, let me just show you what they show here. I'll share my screen. Let's see. You should see my screen now. So here, let me see what they do here. So here's a calibration, how they do calibration plots. They talk about it here, but I'm sorry, I'm scrolling around to find out where I need to be. But I think this is right here is a typical, that's a good calibration plot where it's closely calibrated. Like the probability is there's a lot of confidence in your probability score. And see, I guess this is kind of showing you the bins in the bottom here, but they bin it so like it from 0 to 0.1 and then 0.1 to 0.2 and 0.2 to 0.3. With each one of those bins, you get an idea of your level of how confident, how correct your model is with its probabilities it's returning. So
that's for the model that gives you probability at the output. So it gives you the answer, but also gives you probability.
Yeah, well, this is a it's a calibration plot, and they show you how you generate it here. But
but the model that you're calibrating gives you the correct answer and probability of correct answer.
Yes. Well, no. Well, the model is just a classifier. Okay. It's just a like in this case, it's just a logistic regression classifier, like any classifier, and then you run you use calibration on it, and you could generate this graph, and you could see that with this calibration for the SVM, that was a logistic regression, but the SVM for the same data, I don't know what kind of classifier it is, but it's a binary or some sort of multi-class classifier. Then here you could see a bad calibration curve. You see how the curve for the classifier in these lower bins is performing poor, it's producing lower probabilities, and then over here it's producing higher probabilities. So it's not giving you very you can't be very confident in the scores you're getting out of this model. So then what you do, so this is, I don't know better than you really, I just am beginning to learn this, but then what it does is you run this calibration, and you see here the calibration classifier. That's just a you know, a class from scikit-learn, and it does this to it. It fixes it. Okay, so here's your SVM now after running the calibration. And so somehow it's recalibrates your model, and it's basically lining up your probability scores.
Oh, that's really interesting. So it's very similar to what Sujit or you were showing, I think last time we met.
Yeah.
For like deep learning, doing this temperature annealing thingy on the end of deep learning. Yeah.
That's exactly right. And I couldn't remember what we were discussing then, but yeah, the temperature annealing. It seems very similar to this. So what I don't know is, I just came across this when I was doing some graph stuff, but I don't know when it's critical to do calibration on a model, and I don't know if you can do it on all models. But and actually, what I really don't understand, or I'm curious to understand, is calibration. You know, what does it actually affect in your model? I mean, is it, you know what I mean? Like, is it actually altering your model somehow, or is it, you know? So anyway, there's a bunch to understand.
Okay. So I still have a question. So, but I'm assuming that I guess it's important when people like, in a lot of cases, people really don't like. That always like surprises me, but a lot of users do not care, because I've been like developing something, and I was saying, well, let's give them probability, the confidence of our answer. Everybody said, no, we just want rank choice. Like, give us number one and maybe 2 or 3, and if it's really bad, then maybe indicate like the probability. But yeah, we don't care like what probability model tells us.
But you know, I got the same thing, of course. And I think that one of the examples they give and why calibration can really matter is if you're doing, you know, like medical stuff.
Yeah. Oh yeah, yeah.
Right.
So also like with us, like one of the more, and I'm thinking like I might like see, we're developing one model, and I want to see if I can apply it there, because there basically people gonna do financial betting based on the model. So it's also, you know, it's kind of, you know, I think we have to get probability correctly there.
Yeah, this also here in scikit-learn, they say that you can use the calibration to create a probability in a model that doesn't produce probability. You know, you just have a binary, a model that produces true or false for each class.
But that's what so this is what I don't understand, right? So so you have you apply a model to a bunch of like validation data. So, and but in order to bin something, right? So you need, in order to bin it to some probability bin, you need to give it a probability. You can say like, well, this probability of this answer is 0.45, so I'm going to bin it to 0.5.
Yeah.
But like model itself then has to produce not just the answer, but also probability of the answer.
Yeah. So right. So you're asking, how do you create a probability when you don't have probabilities coming at it?
You know, but let's say for the models that do have or output some sort of because anytime you have you know, you have neural networks, you have like soft argmax and like stuff like that. You like, if you don't pick one answer, if you give like the, you know, a bunch of answers, then you can basically say like, well, we pick this because its probability is much higher, but you actually have the number.
I'm not sure what you're asking.
So when you give when you use that class, right, the calibration class, you have to give it the model that outputs probability, not just the answer.
Yes.
Yeah, see right here, here it is, and that's CG says yeah. So CG, you have some experience with calibration?
No, not really. I just read the temperature thing that Yuri then shared with the other, yeah, the temperature scaling. So that's where I got this idea from. Yes. Yeah.
Yeah. So I'll just catch up here. So you see, I was doing graph stuff and came across calibration. I'm like, what's calibration? So I got this article, and it shows here they take a logistic regression classifier and a SVM, and they, sorry, I'm scrolling through here, and they do a calibration. They calibrate it here with a graph. So that they bin the ratios, I mean the probabilities that are coming out from the model, and then they do this. So you could see that this logistic regression is like almost perfectly calibrated. So at each point in the probabilities it's returning, whether it's giving you a 0.1 or a 1, right? The confidence of those probabilities is high. Okay, that probability matches what's the reality of the situation. And then here's one for the SVM, and the calibration's all messed up, right? Because it's giving you low probabilities when really the probabilities should be higher, and then over to the right, high probabilities when they should be lower. And then you use this scikit-learn calibration class, and it calibrates the SVM. Okay, and my guess is that once you've done that, you have much more reliable probabilities coming out. You probably have a better curves coming out of your output. And what I was thinking, Yuri, is that maybe that helps when you're doing a threshold, or when you're turning this into 3 different levels, right? Like you were talking about, just like, okay, good, great, however you're doing it, right, for your users. So, but anyway, does that make, Suji, do you see what the basics of the calibration is?
Yeah, there's also this curve on the bottom, the histogram. It reminds me of in Snorkel, you basically see how good your how good the generative model has learned, right? By plotting its probabilities, and if you get this kind of U-shaped curve, then it's a good thing for a binary case, right? Okay. You want this kind of deep U-shaped curve, because
so look at the bad curve.
Right, exactly. Yeah.
So what is it showing us here with those are the bins. So what they bin the probabilities of the x-axis here, they bin, and then they do a ratio of correct results.
Yeah, I think it's it is very sure when it's 0 and it's 1, right? So it's not a wishy-washy thing, right? It doesn't say maybe it's 0.5 or something, right? It's either like, I'm sure it's good, or I'm sure it's bad, right? So that's the kind of intuition I get out of it.
Yeah. So I don't know. It's just like an early exploration. Is that I have to really use it on a model and see, what it actually does to the model, because you're calibrating it to almost change the model. So when you move it going forward, it probably gives you smoother. I'm guessing it might actually give you smoother precision recall curves too, which helps with selecting thresholds and stuff. But so Suji, you've never actually used calibrate, had a situation where you have to use it, have you?
There's no. Yeah. I came to know of it from another group, which is starting to use it, and I don't actually know the use case they're using it for even.
Right.
I just got the temperature calibration thing, so I shared it. Yeah.
Okay. All right. I'll stop sharing my screen for now, and we'll move on to other people here. Is there anyone who wants to? I think we have a new guest here. I don't know TYO213, but if you'd like to tell us what your name is, that would be great. You don't have to, but.
Well,
Oh, can't hear you very well.
let me try again. Can you hear me now?
Oh yeah, sound good now.
Okay.
Oh, I think that you're coming in and out. Try again. Yeah, you have not a good voice connection. So sorry.
Okay.
You could there is a dial-in number too, if that helps. Do you have that? Do you if you want that, I'll text it to you.
No, I think I will just say that I just join on the weekends normally, and I am just checking what is going on here.
Oh, I can hear you now. What's your name?
David.
David. And
Yeah.
what's your last name? Uh-huh.
Yeah.
And yeah, I mean, normally we just go around and share what we've been working on at work, what we've been learning about, what we saw that caught our eye in the news, that kind of stuff in terms of NLP. We're very NLP focused. And but it's pretty an open, free form. And if you have problems that you want to discuss, you know, the three of us that are on here are pretty experienced in a variety of areas, and are glad to help with issues as well. So is there anything you want to ask or, you know, or discuss that's on your mind?
I think for the moment, no. But
Okay.
thanks for the offer. Yeah.
Okay, well, we'll circle back around probably. So I have a couple other things I could share, but I'd rather let's move on and see what you guys have. Is anyone else who wants to has something they want to talk about? Ask questions, or share?
I can go. So I'm Yuri is too. We are both attending the graph tutorial as well, and it's homework time now. So I finished collab 0 and 1, and I'm working on the homework right now. So that was, you know, it's fun. On the collab 1, there is a nice homegrown, you know, creation of graph embeddings, which I thought was pretty cool. Essentially, they create positive examples of edges, you know, nodes that are connected, and they take those as your positives, and then they sample an equal number here, an equal number of negative pairs where nodes that are not connected, and then they train a very simple, you know, like one layer embedding layer with a sigmoid on top, and they train it for 400 epochs, and it does result in the weights. So essentially, you start with uniform weights in the embedding, and then once the 400 epochs of things that, you know, training is completed, you look at the weights again, and you know, project it to 2 dimensions, basically PCA, and it does show a very good separation. So that was a cool thing I kind of learned from the collab.
Was that a graph stage, or is it simpler than that, huh?
It's actually super simple. I can share this if you like.
So you know what's funny about that? Yeah, please. You know what's funny is I've just started learning graph on my own, and I just did the stellar graph, and I did an embedding with Graph Sage, and it's basically exactly what you're talking about, except for, you know, like the more full version of it.
Right.
So I'll show that to you too. So
Okay.
show me the simple one.
Okay, hang on. So I'll get this, share. Let me move this guy over here.
I think I should catch up on those recordings for that class, but
yeah, it's moving pretty fast. So you know, that's the downside. It's very tight, but you know,
how are discussions themselves? Like I actually, like, I wasn't able to catch up yet because there's like another thing, the Kaggle thing is at the same time slot.
Okay. Discussions are more like here. It's very free form. It's not like DL PyTorch where somebody leads the discussions. I missed so I took I attended the previous week. The week before I missed because I was in Las Vegas. I think the week before the one I missed, Wendy did try to, you know, kind of lead the class for a while. But last week it was more like, you know, people had questions about graph embeddings. And I pointed out that if you knew what to vec, this was like mostly like what to vec, right? where your sentences are random walks, and you basically do word to vec on the nodes. And that basically was most of the discussion, right? So we just kept going back and forth, and we didn't actually touch the study material. So I think the approach is like you study up, you basically ask questions, and and it becomes like a free form discussion.
Okay.
I got a question for you before you start. So the graph embedding notebook I went through
Mhm.
with Stellar Graph, the data was papers, and they're linked. And each paper has a bag of words embedding. That's its feature, right? So each node is a paper, and each node has features, and the feature that it has is this, well, features, bag of words embedding, and then from that it creates, but anyway, what's your data like for this? Are there actually
Oh, this is the Karate Club data set.
and
Right.
does that also have a bag of word embeddings for each node already?
No.
So that's okay. So my little keyhole into this stuff is so narrow that I'm like, I'd like to see it create embeddings when you don't have text and a vocabulary and a bag of words. You know what I mean?
Right. Yeah.
Okay. Interesting.
So, yeah. So
Good.
in this case, this is kind of okay. There is some similarities with bag of words in the sense of the one-hot encoding stuff, but this is what the network looks like. All it is a bunch of nodes. It's 34 nodes and about 74 or 78 edges, I think. Right.
And do the nodes have any data with them?
The nodes
Like,
don't have, the nodes actually have some data. They here
like a name. I mean, obviously they have ID.
No,
yeah.
they actually don't have anything. Well, none that is being significantly used here. The Karate Club network is basically, historically, is basically factions created in a Karate Club, like participants, between participants, and they kind of become factionalized. And so the idea is to figure out how the factions will occur, right? So, so that was the thing there. And here, let me show you. So before I go into the depth, so this is what the embedding weights look like before the training. Okay. And this is what the weights look like after the training. So the blue dots are the ones that represent edges that are not connected to each other, negative pairs. And the red dots represent pairs that are connected to each other, right? So, well, actually, no. There are two classes, negative classes and okay. So it's basically like word to vec, but so the idea is that you take all the nodes that are connected to each other and treat them as one class, and you take all the nodes that are unconnected to each other, treat them as another class, right? And then here, so for each pair that comes in, so you have two node IDs and you have a label, right? So for each pair that comes in, you create the embedding for this. The embedding is against initially a randomly initialized embedding layer, and with uniform distribution. So therefore, that's why the first scatter plot you saw was kind of jumbled up, because that represented the unordered weights, right? Untrained weights. And then you take the embedding, then you do a dot product of them, and then you take the sigmoid, right? And that's your prediction, whether the nodes are related or not related. And then you calculate the loss based on the label that you got and the prediction that you got, and you just train it, right? And I'm calculating loss and accuracy. So I'll show you the embedding layer. It's actually like super simple.
So connected versus not connected probably means within a certain number of lengths, right? So
No,
is that right?
No, exactly connected, like connected by one hop, right?
Okay, so you could probably you can define that probably. If you had a bigger network,
yes,
you might make your neighborhood bigger. You have a very, very tight neighborhood. I get it.
Yes.
Okay.
And this is more to illustrate how embedding works.
Yeah.
Right. So this is like a toy network, toy example, everything.
Yeah.
But I like their way of doing it, because like this doesn't even, so if you think about this network, it's like a single embedding layer with a sigmoid on top, right? Which is very similar to what Word2Vec does as well, like a very shallow layer. And then you train the network on a pretext task, to classify whether these are connected or not connected. And then as a result of that, the side effect is your embedding, and which you can then use for this, for figuring out whether nodes are, or clustering nodes in this case, right? So clustering two categories of nodes. So here there is no separation, and then down here, the separation is much better. So that's,
and that's of course without any message passing, because there's no messages to be passing from each other practically, and you only have one hop or one link in your neighborhood.
Yeah, and this has nothing to do with graph networks at all at this point, right? It's like super simple, dumb, how to do graph embeddings. So,
yeah, it's the foundation.
Yes, exactly. Right.
You want me to show the
yeah, absolutely.
The next
Okay, stop sharing. Yeah, yeah, this is actually good news. I mean, Keras is kind of behind the curve a little bit, but they come out with really solid products. I think,
and in fact, that's what Stellar Graph I think is.
Yeah.
Tensor, or is it TensorFlow, or is it?
It's Keras and
Keras. I think it is Keras both. So not that it matters that much, but let me see. Am I sharing my screen? What's going on? I am so.
I stopped sharing, so.
Okay. There you go. I'll get it. I'm still on vacation, guys. I'm not quite.
Okay, it's here.
Wake. It's 7. It's kind of early here in Hawaii, so.
Oh, I see. You're in Hawaii now. Nice.
Yeah, it's 3 hours early. So it's not that early, but
right.
Yeah. How was Vegas? Did you have a decent time?
Yeah, it's all right. It was hot, like really hot.
Oh.
But as the Uber driver said on the way back, he said, you come in summer and you complain it's hot. And what kind of thing is that? I said, okay, I will not complain.
Yeah. He put you in your place. You know that it's going to, I'm going back to Washington State, my place up there. And next week it's going to, this is in the mountains at 25, it's not hot, 2,500 feet, but it's going to be freaking 108 degrees. It's never been that hot up there. I mean, what the fuck? I hope the whole place isn't burned down.
Yeah.
Oh, God. Okay, so what am I trying to do here? I want to show you guys the, that's the calibration stuff. Let's see what I got here. I got too many things open here. All right, there's Stellar now. So what I did is I forked the, so, I'm in GCP here. I've got in Vertex, I've got a notebook. Here's the notebook servers. And I've started a notebook server, and then I forked Stellar Graph into here just so I could play with the notebooks, and and then I could save notes on them and stuff, right? It's kind of nice. But here is I'm trying to find the, okay. So what's really interesting about GraphSage, what I understand of it just from reading about it yesterday, is, so this is an algorithm, it's an implementation of it, but the Stellar Graph, first of all, Stellar Graph is kind of interesting because they actually have a ton of algorithms you can use. Okay, now I did GraphSage just because it seems like a pretty state-of-the-art, sort of, or close to it. But here's Stellar Graph, and let's see the documentation here to get some idea of the different algorithms you can use. Let's see where it says in here. Algorithms. And it's fun, right? Because it has so many. It's got the Word2Vec kind, and then it's got the message passing kind. And see, look at Node2Vec. And then it's got this MetaPath to Vec. So it's got all of the evolution of the different, sort of Word2Vec methods. And then it has, is GraphSage in here? Is it showing everything? There's a clustering, there's GraphSage, there's all sorts of stuff. So you can go through the whole history practically of the evolution of graph embeddings using this. And so I started doing it with with this notebook. It's a little bigger here. And they use, what's interesting is they use unsupervised training to train your embeddings. And the way they do it is, it reminds me of math. You know how you do, it's really self-supervised. They don't call it that, but I think it is, because you remember the self-supervised where you do the math language models, right? And it's self-supervised because, you know, they're using sentences and you're just masking words.
Exactly.
So you don't have to label any data. And so they kind of do the same thing, which is exactly what you talked about there, Suji, but a little more complicated. So it has this walker class and these capabilities where you can randomly or use different kinds of walks. But what you do is you grab positive and negative examples, and a positive example is connected, right? Two nodes that are like an edge, that's two nodes that are connected. And a negative example is that node, another node that node is not connected to, right? And then what it does is it has this encoder, decoder, two of them, I think. And it classifies, somehow it does a binary classifier. So, and it says connected, not connected. So you're just training a connected versus not connected binary classifier for nodes in your network. You sort of with me so far?
Mm-hmm.
Okay. Then what that does is that trains your layers, right? And your weights. And then somehow, what I don't quite understand, I'll show in the notebook, is then because it's tensors in you know, in Keras or in TensorFlow, you grab those weights or those tensors, and then you use those to create an embedding model. So you've got these weights that were trained based on a binary connected, not connected. And then from that, you can just generate embeddings for all of your nodes. And then and then in this example, in this notebook, it uses those embeddings for a downstream classifier, node classifier.
Yeah.
So
The idea, you know, it's kind of a repeat of, yeah.
but doesn't that seem like self-supervised?
Oh yeah, it is.
Yeah, no, they don't say that anywhere though, but they call it unsupervised.
That used to be the term before self-supervised was coined, right?
Yeah. All right, so loading, here's the Cora network. Are you familiar with that one? That's
Yes.
right in your book, that's in your field there, right?
Yeah.
And
But Cora network doesn't have text. So that was my main stumbling block. It's actually, you know, they have extracted the citations and they have just created the edges, and they give you the edges. That's the Cora network dataset.
well, they also, so here's an example of, here it is. I downloaded it. So here's the ID, and then here's your.
So these are the vectors.
Yeah, these are just your, you know, your bag of words, right?
Yeah, exactly.
And so that's the whole thing, really. And then they give you a class. So I guess there's three parts to it. There's also a classification for each.
Right.
I mean, that's probably the main value of it. But they don't give you access to the text, you're saying.
Exactly.
That's,
yeah.
That kind of sucks. So that's what they use as their data here. And they use that for a lot of the telegraph examples. But I just do a little EDA to look at the classes, so you could see, you know, neural networks. A lot of the papers are about neural networks, all that kind of stuff. And then so I mean, I think I've explained it mostly, but I'm not sure what we want to do here. But I'll show you. Oh yeah, like you showed, Sujit. I'll show here. What they do. That's how you. That's what you get right there.
Nice. Okay.
You do a t-SNE of the embeddings you end up with.
Right.
And then they do a classifier based on it, the embeddings down here, but that's not that important. They just see they're doing a logistic regression. But what is interesting to me, that was a little hard for me to understand, was some of the stuff where they actually go from the binary classifier to sort of stealing those embeddings. So let me look here real quick. Maybe I could show that to you. This is just showing the architecture of the embedding model, but I'm trying to understand it. Building a new, okay. So above this point is where we're doing the training the binary. Okay, up here. So this is the, they explain it real quick here. Let me see. There you go. So this is where they're explaining how the algorithm works. Listen, talking about the walk. Anyway, I don't know. So this whole part is the whole binary classifier, and then down here, I'll just see if I can show you here. See this part right here. They're stealing these pieces. That's actually from, I don't know if that looks familiar to you, but that's from up here where they create the geez, this is hard for me to follow here, sorry. All right, well, whatever, I'm missing it, but they steal parts of it. So anyway, it's doing a lot of stuff for you. So it's kind of hard to follow exactly what's going on. But the color coding there are the you know, we just looked at the data set and they have classifications.
So it reflects the classes there.
Yeah, so what it's saying, it's just trying to show you that, let me go back to it. It's just trying to show you if it actually semantically clustered them.
Yes. So essentially, if you think about this, you're learning to, so this network, the graph stage network, is basically created to predict the class that the Kodak paper has, right? In the same way, it was built to predict whether two nodes are connected or disconnected in my case, right? And in the process of doing that, it learns, the network learns an embedding, which learns to distinguish between these classes. Right?
No, actually, no. So what you're looking at here, it has not seen the classes at all. This is completely unsupervised or semi-supervised. And so they do that, they train the weights, be that binary classifier, which you're familiar with.
Right.
And then you steal those weights and you put that into some sort of an embedding, a model that can generate embeddings. Then you generate embeddings for the nodes, and then you t-SNE them, right, into this. And it shows you those unsupervised embeddings actually produce semantically aware embeddings, right?
Okay. Yeah. So
That's
basically position of the nodes on the random walks, right?
Yeah, it's learning just like the math, you know, learning. It's actually just doing exactly what you did in your simplistic one, in the sense that, I mean, it's got message passing and stuff like that, so more information coming into it, but it has nothing to do with the categories at all. It is using that. It's using that bag of words for sure.
Right. But indirectly, it is learning learning the separation that corresponds with the categories, looks like. Yeah.
Well, it's not learning the separation that corresponds with the category. It's learning the separations that correspond with meaning, because the assumption is that, yeah, the assumption of all of this, just like with sentences, right? The assumption is that these, that the different geographically or whatever, the different sections of your network, right, of your graph have some sort of things that are connected are semantically related, which of course is true, because this is a network of papers that are citing each other. And so so this is just, it's just learning that in an unsupervised way. This is just proving that, yeah, it is picking up semantic meaning, the embeddings. And then it uses those unsupervised embeddings you generated for a downstream task for those like 10 or whatever categories of papers.
Yes.
Okay. So all it means is you can use GraphSage to take any graph where the connectedness is related to, you know, its meaning or whatever. There's some meaning in that. And you can just you can convert into this using an unsupervised method. You can convert into embeddings, and then you can do all sorts of stuff with it, right? That you'd normally do downstream. But it also has built in, there's these other notebooks where you can actually not do all this embedding stuff, but still do node prediction. So StellarGraph has stuff built in, and you can just use GraphSage and they do edge prediction as well. So, but just one last thing is that I don't really understand. I still am very beginning of this, because there's real I'm having a hard time figuring out why I would use this, because you have freaking transformers, right? So this is a network of papers,
Mhm.
So this whole example is just showing how you create embeddings, then you use those embeddings to do a classifier, right? I wouldn't do it this way. I mean, I bet I could take the same non-connected data, use state-of-the-art graph and compare it to Hugging Face, right? You know, sort of the state-of-the-art NLP.
You can actually. So what the graph methods or graph neural networks give you, not embeddings by itself. So, and this is from the Leskovic lectures that I think number 3 or 4 that I listened to. So it's a very nice way of thinking, right? So he says like, you know, the old methods, traditional pre-neural methods, where people used to assign features to nodes, right? Say, okay, you know, this node belongs here and is connected to this, it gets some information from there and so on. But the features were assigned to nodes manually. With the move to embeddings, you said, you know, that I do not want to assign features normally anymore. I will assign whatever the graph tells me. So the graph structure dictated the embeddings, right? Or so the embeddings for each node became the feature vector for each node, which was assigned by the graph structure. The characteristics, the features of the nodes themselves were ignored in this case, unless you concatenated them, you know, with the manually created features. Now with graph neural networks, you can not only take the graph structure into account, or also its features. So features that you have extracted from your bag of words, for instance, right? Plus the citation structure. So the thing that it gives you over and above the transformer-based models is that you are also taking the signals that are in the citations, you know, the structure of the graph into consideration, in addition to.
So let's do a little thought experiment.
Right.
So Roberta, let's just say I have a fine-tuned Roberta,
Mhm.
or Bert or whatever. I could take this, if I had access to the text of this Quora graph, right? I could just simply manually, before I even run any of this, replace these bag of words with my fine-tuned Roberta representation.
Yes.
So then theoretically, maybe what you're saying is that the results I would get without using the graph stuff, when I use the graph, I'm getting an extra edge, not an edge, but an extra, because it's going to use the neighborhood.
Exactly.
So ideally, I'll actually get even better results if I just take all this cutting edge NLP stuff and embeddings and shove it into the whole graph then.
Theoretically, yes. But practically, you are using Roberta as a static embedding generator. So you're not passing back. So maybe if you could, you know, train Roberta in the process end to end, right? Fine-tune Roberta with your citation graphs.
Yeah.
Then
with the graph.
Yes.
Huh.
So
How do you
in that
find
case, well, I don't know. So
no, but look, theoretically, if you fine-tuned it, you have the best embeddings you can get. And then if you run a downstream on the fine-tuning versus running a downstream on that fine-tuned embeddings that are in your graph, right? You should do better with the graph because it's getting this connected information.
Yeah, I think if you compare with treating, using Robot as a static embedder and then getting embeddings and doing a classification, and compared to, you know, taking the embeddings from Roberta, sending it through GraphSage and then doing the classification using that combination, the GraphSage one should win. In fact, there is it's not as complicated as Roberta, but there is a YouTube video, if I can find it, I will send it, where somebody did a PyData conference in Cyprus, I think, or one of the Eastern European countries, where she showed that, you know, the classification using simple bag of words kind of thing versus classification with bag of words plus graphs. And the graph won, I think. It's not like a simple neural network based. One was, you know, pure neural network. One was a graph neural network.
Yeah. So I mean, the only thing, so that makes sense, but it still doesn't really answer usefulness, because for us on this call, you know, we're not academics. We're not trying to beat a benchmark, right? So we're never going to need to really, let's throw this in a graph to get an extra 0.02, whatever. But I was thinking, you know, I'm currently doing a page typing. I think I've discussed it, where we have the software vendors, we have their I have, crawled their sites of software vendors. And so we have this huge collection of software vendor pages. And I'm currently using regex to classify the page type. That's not a semantic. It's not a meaning thing. It's about us page, product page, thank you page, contact us page, right? I'm doing that. And then I'm using the Google Vertex. I'm training a classifier. It's working really well in terms of accuracy. I'm bootstrapping off the regex stuff I'm doing because we need more coverage because regex doesn't have good coverage. But then I was thinking about this stuff. Each website is a graph. So they're small graphs. But if you could do node prediction, right? Maybe I can combine all of the web pages into one graph that I don't know if it helps, but you know what I mean? That's like are all connected by a parent node that just says software vendors. I don't know, but the idea is I was thinking the real affordances of this graph stuff is you could do node prediction and edge prediction.
Mm-hmm. Yeah.
But node prediction, maybe I can take from the the highly confident regex results I have, and you have like a graph. A page is a graph, and a site is a graph, right?
Mm-hmm.
Website, each node is a page. And then you'd have like, let's say 40% of them have been typed, have been classified already. So they're known. And then, so maybe you train on all of the sites, right? So that's why I say you put them together as one big graph, sort of. I don't know if you can do that or not. I don't, that might not work because they're not really connected together, right? The websites to each other. But, and then you just do a node prediction, so I fill in the other 40 types with types.
So
I don't know.
Would subgraph isomorphisms be useful to you? Like if one graph looked similar to the other, you could kind of say that these are similar things. Does that mean
I know what you're saying. The problem with thinking in subgraphs is first of all, a website is a subgraph to begin.
Right.
I mean, a website's small, right?
Right.
But yeah, that's another way of thinking. That's interesting. I mean, the problem with all this is that, first of all, sites are very different sizes. Most of them are going to be pretty small. Mm-hmm. Maybe they're too small to do much with, and you can't really connect all of these sites as subgraphs, right? Because how are they connected to each other?
Right.
So, but anyway, that's all I have on graph.
Yeah, there is some applications to NLP. So things like link prediction in knowledge graphs is a useful thing, right? Where you have, based on what you see, so between, say, pairs of nodes, you already see that some of them are connected. And then you see that some of them are not, but they are really similar, the two pairs of nodes to the two other pairs, right? So you can then suggest connections and so forth. So those are.
Yeah, I mean, obviously that's a really interesting one. Is if you have a situation where I bet Yuri has a ton of this kind of data that's connected.
Yeah, actually, I have a question. So I don't know if you've seen the use case where you're not looking like yeah, we are looking for sometimes we're looking for missing links or links that were done incorrectly, but like recently we've been trying to do it by comparing our graphs to other graphs, because a lot of people, when they catalog their products, they also have they also have graph structure. Mm-hmm. And right now we're just doing it sort of manually because we already mapped a lot of other graphs. But I was wondering if you've seen any projects or software packages where one would compare two graphs to each other.
I haven't.
Huh. Yeah, that's a good question. There's actually an expert on this who wrote the Karate Club stuff. This guy, I think he works for a pharmaceutical company. I heard a podcast with him. I'll try to post that, because it was a little too sophisticated for me, but it was interesting. And I think he might have discussed that, actually, Yuri, in terms of a need. And maybe, I don't know, he has like 4 different open source libraries he's created. I don't know if, here it is right here, hold on. The guy's name is, oh my, I can't say his name. Anyway, I'll try to look it up while we're talking.
Okay. Oh, I posted the YouTube video, by the way, in the chat.
For the class?
No, for the Cypress, PyData Cypress talk.
Oh, right.
Yeah, so that one.
Yuri, have
Oh,
you
by
been
the
able
way,
to
I
use,
have a-
have you used any graph embeddings? I mean, you guys seem like a great use case for graph embeddings.
So we have homegrown version of this. But let me ask you before I forget. The stellar graph. How did you? Why did you pick it, or was it like a?
It's a good question. Well, what I did, it took me a while to get to it, but let me look at my notes here, because there's other graphs. Okay.
And we're already using 2 or 3 graphs in our system, so chances they're not gonna like want to use like 4th or 5th, but you know.
Dude, you guys should be using a library because it's pretty well developed. There's also DGL isn't a big one. You ever heard of that one?
Yeah. DGL is from Amazon. It's good.
Oh, which one?
Yeah. I'll pay. I'll post it.
Deep graph library. Yeah.
Here he is right there. So what I did is I just started reading about all this stuff, right? And I came across the stellar graph, DGL. There's also lots of things, like some are better for heterogeneous graphs, you know, like knowledge graphs, and some are better for homogeneous graphs. PYG is another one. It's PyTorch geometric. Yeah. Here, I'll just put the name in. I don't have a link to it. There's PyTorch geometric. There's also PyTorch big graph, but that's just a scaling thing. You know what I mean? That doesn't do anything special different. Those are the main ones I came across. So that's stellar graph, PyG, DGL, and
there's one called Spectral.
Yeah, Spectral. Okay.
Yeah.
And,
but that's not as like advanced as stellar graph.
Yep. Yeah, so I don't know what I did, you know, as I started learning about the different and sort of the history of the different algorithms, not mathematically, but in general. So how it evolved from skip gram to deep walk to node to vec, node vec, whatever, and then it moved into message passing. So there's sort of the wandering and walkers that come out of the first phase. It parallels all the NLP stuff, right? With glove, word to vec and glove and whatever, and then it switches into this message passing kind of algorithms, GCN, and so those are what is it? Anyway, they have, and then from that I found libraries, and then I found libraries that sort of why I moved to stellar graph. I've maybe decided that I'd invest time in that one after doing a bunch of research, is because it allows you to use all these different algorithms, and each one probably has slightly different affordances. It's a great way to learn, and they have a ton of notebooks too. So anyway, does that answer your question? Yeah, I mean, dude, if you guys aren't using a library.
Yeah, we actually, I don't know if you can hear me. Okay, I had to switch to the car, but yeah, so we have like pockets. So we have actually Neo4j in something. We have Allegro graph in another application, and we actually just started using Web Protege as for the ontology itself. So
yeah, those are graph databases though. This is a graph library, so there is no overlap. I mean,
Well, it's not just the graph library. Let's say it's embeddings. So what you need is a graph embeddings library. And there's, yeah, that's a completely different set of technology.
Oh, okay, okay.
Yeah, yeah, because
yeah, because I haven't done graph embedding.
So
So what we've done is it's not. I think I described it before. We have our own sentence embeddings and sentences in graph, the values of parents and the values of children.
Mhm.
So we use graph to just the pure embeddings. But I always kind of wanted to try like a more standard way of using graphs.
well, you know that I did notice that I think Neo4j like has graph stage algorithm built in. I'm pretty sure I saw an example where they were using it. So I think that some of these, Sujit, I think that some of these graph databases or graph stores are incorporating embeddings into them. So you might have that at your fingertips, Jerry. And they may already be using that.
No, but also when we're building neural networks, we don't touch we just use ontology from like CSV files. So far we just our data is in CSV files, and it basically has like each item has ID for the parent. So we can, or the other way around. Each parent has IDs for the item. So we can basically, like our graph is just stored in the flat file.
Exactly, right. So yeah, you can use the graph as storage, and like Darren says, like I know that Node2Vec is built into Neo4j. GraphStage might be too. They are moving pretty fast, but yeah, you can do it inside or outside if you want to. But for neural networks, I mean, you would need the data as flat files, dump from your ontology.
By the way, I just posted the podcast link, or it's a link to the listen note meta page for the podcast. But that's the podcast with this guy who, this Benedict guy, and I think he talks about comparing graphs in there. I'm not sure, but anyway, you might be interested in that. I also put it in Slack. So, okay. All right. Anything else you want to talk about with graphs?
Oh, well, not on graphs, but talking about what Yuri just mentioned about SentenceBERT. I tried using PySerenity with, so PySerenity is a Python interface to Lucene. And lately they have also included dense searchers where you can plug in your transformer-based passage rankers, right? So I tried that, and zero-shot SentenceBERT actually sucks, right? Or at least it sucked for my use case. So I was trying to extract Cord19 data, search for Cord19 data. So I used the COVID-BERT SentenceBERT. So it's like the transformer is tuned or trained with Cord19, but then the sentence piece, right, the SentenceBERT piece is trained with SNLI dataset, which is general English. And I was trying to get queries and documents in the same using SentenceBERT, right? Find similar sentences and then find the documents containing that. My results were pretty horrible. So my next step is basically to try and train SentenceBERT at some point for Cord19 and question answers. So yeah,
you would think though that it would be better than just shit before you'd want to do that. You know what I mean? Because fine tuning only is going to get you what? Typically 5 to 20% maybe. Right. So were you not wasting your time, are you?
Well, that's the thing, right? I do have to, one of the things I plan to do is actually look at the results. So I was using Trek COVID, the judgment list from Trek COVID, which has certain amount of manual bias because or biased towards Lucene-based kind of things, because the basic data set is created based on feedback from people, and then they do manual review of that. But I think I should have gotten better results. I will look at the results from the searches that I'm getting. I mentioned this to Jimmy Lin's team, the PySerenity thing, and they said you have to train it, otherwise results are not guaranteed, which probably means that, so they point to the MS Marco data set. They have, they have a full, like a Lucene index and a model and everything all pre-built, and those gave great results. So yeah, so I think, yeah, you're right. I mean, it might not actually give me very good results even if I train it, but and maybe I'm missing something here too. That's also a possibility.
Right, and once you fine tune it and it's still shitty, then you'll be able to say, well, maybe I am missing something or doing something stupid, right?
Yeah.
So I'm sorry, what was the task exactly? What's the search for what and get what?
It's basically to increase, so the objective here is to replace the Lucene-based candidate or passage generation or passage retrieval process, right? So essentially, when you do question answering, the question goes in, it goes into the index, and you try to find passages which could be candidate answering passages for the question, right? And so you get that. So previously we were using Lucene, and
yeah, this is like a Cora. Basically, you're getting the grist for the Cora type QA system.
Yeah, well, it's different from Cora. Cora is finding similar questions, right? So given a question.
Oh, no, I'm sorry. Squad. I meant Squad.
Yes.
It's like you're getting the pages to extract the Squad.
Exactly.
Yeah, sorry.
Right.
Yeah.
So people have reported much better results when they switch it over to neural retrievers. So I've been looking at so Jimmy Lin, the guy from University of Waterloo, he wrote a paper which is 150 pages long. And it's really the definitive guide to doing this, right? So he basically charts how it has happened over the last 2 years. And first big success was by Cho, the NYU guy, the GRU guy, the guy who invented GRUs, Cho and Noguera. And he got the biggest jump by putting a re-ranker on top of a Lucene index, right? So you basically get the top 1,000 results, and then using a re-ranker, you re-rank it and give back the top 10 results, right? And that gave him a huge boost from pre-transformer results. I think on MS Marco, it was MRR at 10 was 0.165, the baseline, and he was at, I think, 0.36 something.
I'm sorry, was the re-ranking, that was the dense vector part, so it was like a regular search with a dense vector re-ranking?
Yes. So you do a regular search, get the top 1,000 results,
yeah,
and then re-rank them using their dense vectors, right?
Yes.
And then take the top 10 and just work with that.
Yep.
So I'm trying to replicate that bit, the backend portion of the question answering, right? So I'm saying that, if it succeeds on, so I have judgment list from Trek. And my point is that, my neural searches should do better than my Lucene searches, right? At the moment, it is not. So I've tried 2 models, and again, I'm reading through that thing, and
so you're not doing just re-ranking. You're doing the actual, Vespa. You're doing actual dense vector searches.
Exactly. I'm replacing the whole pipeline using the dense vector, and that's not working out too well. Re-ranking with FICE actually is a pain to do because FICE doesn't do filtering apparently. So So
you've got a lot of working parts in that.
Yeah,
I'm sure.
Interesting. Yeah. So that was something I wanted to point out that, or actually ask you. I mean, have you got good success with SentenceBot without training it, right, off the shelf?
Yeah, sorry, I was trying to find my unmute button. Yes. So without we're using it with retraining,
Okay.
and without retraining, we're getting, let's say, 60% accuracy. With retraining, we're getting 70% accuracy.
Okay.
So wait a minute. By retraining, you really don't mean fine tuning. You mean retraining from scratch.
No.
Fine
So
tuning.
for fine tuning, yeah.
And
Yeah.
is this a
And
search task? Is this a search task? I can't remember.
this is it's mapping task, right? So
Okay. Right.
we have a giant list of things on the left. Oh, actually, not,
Yeah,
maybe 200 something words on the left and 20,000 words on the right, and we want to like find the matches.
Yeah.
Okay.
I remember.
Okay.
Sure.
And yeah, we so I was a big fan, tried to do it without training, and but yeah, the accuracy is 60%. But with training, we get 70, and we put that into production already, because that's sort of because what also we can do is what we added to that is because ultimately, like, we just want to give high accuracy results. And the network itself does an estimate on, like, how accurate, at what distance we want to do a cutoff. So we have a training set and a test set. So at test set, we basically look at this. It's like equivalent of the ROC curve. We see at what accuracy, at what distance our accuracy goes down, and we take it as a cutoff. So like if we like basically let it pick, if we say, like, just for any item we want to map, pick something on the right, then the accuracy is 70%. But we know that's not always, like, sometimes we just don't have the right answer because we don't have those things yet.
Yeah. You gotta drop your recall. That'll bring your precision.
So we have this threshold, and that, we tune it to be, I think 80 something, 85.
Yeah, that's pretty high. Your recall must be pretty low.
But again, this is just we're gonna, it's gonna be reviewed by humans anyway, so this is just like a suggestion to a human. So
Okay. Yeah.
actually, like, so the principal author of Sentence Bird just recorded 3 short videos for one of the classes.
I saw that.
Yeah, I didn't put it in the discussion, but because I listened to them, but I have not followed his advice. So I think maybe we can improve our training, because he talks about how to pick those hard pairs, not so hard pair, triple pairs. So I'm not sure we did it correctly, because we, something worked and we, like, mocked with parameters and.
Okay. Yeah, then in that case, I should probably revisit. Maybe I'm, blaming something without reason. So I will check.
All right. Interesting. So was there anything else from the graph class, or from anything else anyone's read or looked at or seen they want to discuss?
Oh, I added 2 links. By the way, could you hear me okay when I was driving, or was it too noisy?
Parts effect. There was some breakage, right? You're breaking.
Yeah, you were. There was a little bit of break coming in and out.
Okay,
yeah.
So let me quickly, like, because I have to start driving again, but let me, like, quickly, like, kind of go over it. So those 2 things I'm planning to look at, but I haven't, like, looked at them in detail. So let me look at it. So the second one, the auto know, it's in Amazon it's an academic paper, but it's an Amazon product. And I think that's how they basically build the product graph. So that seemed really interesting.
Okay. That's good.
I haven't looked at details yet. And the first one is the another like projection embedding, a projection variant from Peter Baumgartner. Again, I haven't followed it, but like I kind of like he had the new projection that he called it Procrustes. So that's I guess that he says like works even better, like to maps it into some works better with some factor analysis that he was doing. So
that guy's like a little hero, right? He's like our little practitioner hero. Anytime his word name comes up, like.
All right, yeah, that's all I wanted to say.
Weren't you doing some sort of competition or something?
Oh yeah, no. So the last time when we didn't have a meeting, it was the follow-up on the competition I did in January. They had like they invited the winners, and then they invited 3 people that were helping them, like 3 people who were doing like deep learning and small businesses. I don't know, it was interesting. I will try to keep in touch with them. But
that was the satellite data, right?
yeah, well, it was weather data. Okay, yeah, so I was trying to do super resolution of temperature data.
Right. Now I remember.
Which is still really interesting project. I keep thinking like we can use it at work, but so far we're not. We're trying to stay at very low resolution level. Yeah, because that's how our models work, and But
well, what's your biggest priority now at work? What are you spending most of your time on?
So we have this mapping software that we put together as a research project, and we're trying to use it in production. And making it work is not the easiest thing. So that's.
So you're dealing with nuts and bolts, practical nuts and bolts.
Yeah, and then to train, we train on AWS, and it's a slight pain to set up. So that's the other thing.
How about yourself, Sujit? How's your being on the team, embedded, going? Anything new there?
Well, I'm finding out more things, and it's kind of hard, because so one of the latest things that I found out was like I was asked yesterday for a single data point, and I spent half a day searching for it and getting it. But in the process, I found that there are scripts which run via config files, which is good, but the config files call multiple config files, right? So which is like super unwieldy, and I'm wondering if maybe we should be able to squeeze them down into one config file, right? Maybe with trees in there, dotted notation kind of trees. So that's one of the suggestions I'm going to make. This is like small things like this, more engineering kind of things.
Yeah, but it's attractive to try to. Right. It's always very satisfying. Yeah. So the YAML, are you thinking YAML?
Yes. YAML, like I think they are using the Windows kind of structure, config parser. Python has a config parser, and it basically has the like the Windows ini files, right? You have the section name in square brackets, and then followed by key value pairs, and so. But we can adapt that to more of a hierarchical structure. So that's one of the things I was looking at.
Have you used YAML before?
YAML, yes, I've used. Yeah.
Okay. Okay. Get it.
Yeah, but the team here won't, again, I'm coming in as like an outsider, right? I mean, they
Yeah,
have,
yeah.
so whenever I do these things, I step on somebody's toes, which is not nice. So
Yeah, I mean, I don't even know if there's a real big advantage to YAML. It's just
Yeah,
what everyone
yeah.
seems to be using. So,
yeah, so I'm trying to do as minimum stepping as possible.
yep. And this is related to the pipelines.
Right.
Got it. Okay. Well, let's, I guess we'll call it a day unless anyone has anything else they want to discuss or talk about.
Oh, one thing, I don't know if you guys seen this new class from Hugging Face. That's pretty interesting.
I did see that. They have the first one out, right?
Yeah, I think second chapter was like, it was on Twitch TV live yesterday.
Uh-huh.
I haven't watched, but
Oh, there is a new class for Hugging Face. Okay.
Yeah.
Yeah.
Yeah, it's
talking about Hugging Face on the PyTorch DL channel, Hugging Face announced a community event where teams are taught JAX and they're given TPUs to do training for particular projects. So there is a team forming in the DL PyTorch. It's 7th to 14th, 7 days of TPU. It's like a coding kind of deal.
Yeah.
So, yeah, just in case any of you are interested.
Cool.
oh, okay, cool. Yeah, I just saw the announcement, but I haven't seen it on the TWIML. Yeah, I'll check it out.
Yeah, look at Mayank's post, and with a lot of it's a threaded post, so a lot of answers in there. So you find it there.
I just posted the class as well.
Ah, okay.
Yeah. All right. Well, anything else, anyone?
No.
Yeah, that's it. I think I didn't have anything else.
Okay, great. All right, guys, thanks. We'll get together next Friday.
Sure. Okay, cool. All right.
Thank you.
Bye.
Alrighty.